Modeling data using sinusoidal functions. This gets a little bit interesting. We're going to do this a couple of ways. First, we've got some data here, and this data is the average monthly temperatures for Seattle, Washington. We've got January through December, and then we have temperature. I guess this is average monthly temperature for those given months. We're asked to write a function that models the monthly temperature using x equals 1 to represent January. So in our list, our L1, our x data is just going to be 1 through 12. And then we're going to enter the monthly average temperature for that month. And then we're going to create a sinusoidal regression. And that we're going to do two ways. On my TI-84 calculator, I do have the ability to find a sinusoidal, or excuse me, a sine regression. I don't have a cosine regression on that. And in your book on page 263, it shows you how to do a cosine regression to find that by, well, let's say by hand. So we're going to do it both ways because doing it by hand is kind of interesting how you come up with that. And so I think it's worthy of at least seeing it. But first we're going to do it using the TI-84 calculator. So I'm going to move to the calculator and do it that way. And then we'll take a few moments and do one by hand. Cosine function by hand. All right, I'm over here on the calculator, and as you can see, I have entered my data on the sine function. The data from Seattle on my calculator. I've already got it in L1 and L2, but I need to probably do a couple of things, make sure. I can't remember how I had this set up. One, I want to go to my mode. I do want to make sure I'm in radians. Because our function is going to be in radians. And let's see, I want to make sure my stat plot's turned on. And it is not. So I want to go through there and enter that. I want to turn it on. And we'll make sure my X and Y lists are correct. I see my L list. Well, last time I used it was L1, but my Y list was L3. So I want to change that back to L2. So I'm going to hit second 2. Okay, and let's just look at our scatter plot, make sure everything looks okay there. So I'm going to hit zoom, option 9, stat. Okay, and so there's the plot of my data. Now I'm going to go to stat again. I'm going to go to calc, and I'm going to scroll down until I think it's option C. Yeah, where I see sine regression. And I'm going to hit enter. And let's see, I got 3 iterations, L1. I need to change this also, my Y list there to L2. So I'm going to hit second L2. And then I actually just learned this the other day because I've been using vars to put it in Y equal. It says store regression equations. I'm going to hit store. Little store button, and let's see, nope. Go back store, stat, vars, Y variable. There you go. Excuse me, store. I'm going to hit vars. I'm going to hit 1 for function. It brings up which function you want to do. I'm going to say Y1. And, I don't know if I cleared my Y1 or not. I better look at that. Anyway, there's my sinusoidal regression equation. A equals A times sine times BX plus C plus D. And I have these values for A, 11.8, B, 0.55, C, negative 2.44, and D, 53.35. Let me go in here and look at Y equals. And I better clear out what's there in Y2. Let me see what our graph looks like now. Okay, and there's my sinusoidal function. It pretty well models the data, not too bad. And let's go in here to the table and let's see, because we were asked to see what was our average temperature according to the model in February. I'm going to hit graph. And there for February, which is x equals 2, is 41.82. Let's call that 42 degrees. How about that? All right. So there we used a sine regression equation to model our data. And now we're going to move over and we're actually going to do a cosine and we're going to figure it out by hand. So that should be kind of interesting. Here we've got our data still up here. And now we're going to actually create a cosine function to model this data. And we're going to actually figure out A, B, C, and D by hand by using the maximum values of y and the minimum values of y that's in our data. So let's see here. Let's find first what our maximum beta. So I have a maximum here in August, 8th month, of 66, and my minimum is in January, 41. Now we can find, let's see again, let's say we would have y equals a times the cosine of bx minus c plus d. Okay, now we can find a by taking 1/2 of the maximum minus the minimum. So let's do that. So we got a equals 0.5 times 66, our maximum, minus 41, which equals 1/2 of 66 minus 41 is 25. And 1/2 of that is equal to 12.5. And we're going to find D next, our vertical shift. A, of course, is our amplitude. D is our vertical shift, and we can find it by 1/2 times the maximum value of our data set, y, and plus the minimum. And so let's see, then we got D equals 0.5 times 66 plus 41, and that's going to be 1/2 times 107, or let's see, 107 divided by 2, 53.5. Okay. Now we're going to find our period, then we're going to use our period to find the value of B. And we can find our period by whatever the x value was for our maximum value of y, and minus our month or x value for our minimum. And so our period then is going to be equal to 1/2. And let's see, our maximum occurred in the 8th month, and our minimum occurred in the 1st month. I'm sorry, it's not 1/2, it's 2. 2 times that. 2 times 8 minus 1, which is 2 times 7, which is equal to 14. So our period is 14. Now, remember our period is also, period, I'm going to just use P, is also equal to 2 pi over the absolute value of B. Well, if my period is 14, I can find B then, 14 times, let's say B, it now equals 2 pi, and then B is going to equal to 2 pi divided by 14. So b then is going to equal pi over 7. All right, so we found A, our amplitude. We found D, our vertical shift. We have found B, pi over 7. All we got left is C. All right, so the maximum data occurs when x is equal to 8. And since the cosine of x in its parent form attains its first maximum value when x is equal to 0, we must apply a phase shift of 8 minus 0 units, or 8 units. Now again, our phase shift is equal to c over the absolute value of b. And so if my phase shift then is 8, I can find c. So 8 now is equal to c over the absolute value of b. And we found b to be pi over 7. So then we can say that c, follow with me, is equal to 8 times pi over 7, which of course is 8 pi over 7. And so now if I can find the right room, we're going to write our cosine function. So we got y equals 12.5, our amplitude, times the cosine of, what is b? B's pi over 7, pi over 7x, minus c, 8 pi over 7, close our parentheses, and then apply our vertical shift, which was plus 53.5. Now I'm going to put that in the calculator and see what I get. Again, I'm trying to find 2 when x is 2. So I'm going to put 12.5 times the cosine of pi over 7 times 2x being 2. Well, that's 2 pi over 7. Minus 8 pi over 7. Close that parentheses. Plus 53.5. I encourage you to put that equation in there yourself, substituting 2 for x. And shazam, you know what I got? If I round it to the nearest degree, 42. Just like I did with the sine function. Now, I don't know about you. It's interesting, I think, to note that I can use that hand method, but it's also interesting and a whole lot easier to use the sine function on the calculator as I'm trying to model data using sinusoidal functions.